Hello guys, welcome back to my channel Kajidataonline. In this particular video, I'm going to discuss and explain to you about Wemos D1 sensor. So this module Wemos D1 are going to be attached with our SHT21 temperature and relative humidity sensor. So today we have a special guest. So this is our guest 18650 battery lithium ion. So it's being recorded here as 6800 milliamp hour, so that means it's very huge capacity, but I really doubt that this one is a good battery. In fact, this one is probably the fake battery, and to confirm that statement we are going to conduct a test. So to understand the test of testing the capacity of the battery, we need to understand a few things. So the first one, how many current are going to be consumed by this Wemos D1. After we know already the amount of current that already being withdrawn or already being needed by this Wemos D1 in their operation of capturing temperature and humidity, and then sending the data into our cloud services. So we are going to estimate what is the current. After we know already the current, then we can estimate whether the capacity are met or not met with the operational time. Therefore, we are going to see inside our cloud services whether they have an ample time, which is the longer time, where it's indicate the real operations of 6800 milliamp hour. Okay, so to begin with, we have to connect it with the battery towards the module. However, I'm going to use the step up boost converter over here, and of course there are some current also flowing here, and some changes might want to be considered. But of course, to know and understand how much current will be withdrawn by this unit, you need to do some adjustment, and using our digital multimeter, we are going to cut this wire. We are going to cut this wire, and after we cut this wire, we are going to attach it in a series. After we attach the digital multimeter in series, we can understand the amps, or we call it as a current. So let us dive into that episode. Okay, so I have here a dummy example how you want to measure your current. So the first one, when you cut, you must cut the black color over here, and then you must attach the load. Okay, the load is actually being attached at the red color over here, and then the probe of the black or the ground are going to be attached at the output. So the reason of doing this is because of the current flow. It's being flown from the red into the black, from the red into the black. So similarly with our multimeter, and after you know already how many current are already being consumed by the Wemos D1, then we can estimate the time that are able to be estimated for detecting the capacity of this battery, whether it is a real 6800 milliamp or it is a fake one. Alright, so that is the theoretical part of it. So let's dive into the idea to simulate the output from this example. After testing using the approach that I mentioned to you, we got an approximate of 110 milliamps. That means the current is 110, already consumed by the Wemos D1 for operating the SHT21 and send the data into the cloud services. We are going to use this number 110 milliamp into our calculation in the future. So please stay tuned on the video. I have a challenge here. So now we are having the setup inside the IO Adafruit. We have the 6800 milliamp claim to be, and we have a setup over there with the SHT21. We are going to use this setup. This item, this setup is equipped with the voltage step up over there. So we are going to boost from 3.7 into 8 volt, and then this one are going to be recording the temperature and humidity. We shall see what happened to the Wemos, how long is it take, and what kind of output are going to be generated we really hope that this module can supply more than enough. Okay, so the startup begin at 12:33 a.m. In the morning Malaysia time. So this is the latest one. So if you want to check it out, this link, you can have a look on this link, because it is made public, so that you can see how long before I'm going to, and also the battery are going to be dead. All right, so up there we have another challenge. This one using the Thingspeak with our expensive battery, and then this one with our fake battery. So just wait for a while, and hopefully see something a few days later on, not few hours. Okay, hello guys, welcome back to my channel. So this is the moment of truth, using this Adafruit to help me logging the data. Yesterday we talked about the logging the data around 12 o'clock early in the morning. So now it's already stopped at 4:50 p.m. So let us have a look about our setup. So this is our setup, and the item are no longer operate as what we want. So perhaps in the video, in the later on version, I'm going to explain how this thing happened. Okay, if you can see over here, we got the 8 volt. They already been supplied to our SHT21 using the microcontroller WeMOS D1, and then it is stopped at 4:50 this morning. Okay, ladies and gentlemen, so this is the finding of our experiment. So what we have here is a recorded time of 16 hours. So if you find out, my previous explanation is talking about 4:50 a.m. Actually it's 4:50 p.m. So we got 16 hours, and then based on the efficiency, we can see that we got 28% from the initial time. That should be long lasting, but only recorded on the 16 hours. So in a nutshell, our battery 18650, the red color, named as Ultra Fire, are considered a broken one or fake version. I hope that you enjoy watching this video and learn something for today. Be careful when you want to buy a battery. If you want to learn more, please do like, share and subscribe our channel, and please do comment about your experience regarding the use of this battery. Bye bye.